In this problem, we're asked to find the percent decrease, and if you're asked to find the percent increase, you follow the same procedure. So whether we're comparing the area of rectangles or number of cars sold or number of students in a school, whenever they ask for percent increase or percent decrease, you can use the same proportion method to solve the problem. The first part you should already be familiar with. I think I'll zoom out just a little bit, give myself some room. Okay. To solve short percent sentences, perhaps you've seen this approach. You can put your percent over 100, and then that's going to be equal to another fraction here, all right? Now, this one is the original amount goes on the bottom. All right, and our original amount, it decreased from 30, so we'll end up putting a 30 on the bottom, okay? And up top, you always put the difference. So it's difference over original equals percent over 100. And sorry that got a little scrunched in there, but that's what you got. So each time you have a percent decrease or percent increase, the stuff that I'm putting in black will be on your paper. All right, so we'll start out by filling that in. I'm going to zoom out again. All right, so all we have to do is fill in these spots. And the 100 is already there. All right, the percent, it's asking us to find the percent decrease, so that's just going to be our variable. And a number over 100, that should make sense because that's what percentage is. It's per 100. 30% is 30 over 100. And now for the original, let's see what they give us. It decreased from 30 square feet. So here's our 30. The difference, sometimes they'll give you the difference and sometimes you'll have to calculate it. So these are our two rectangles. What they're saying here, decreasing each dimension by 1 unit. So it was 10 feet and now it's 9 feet. It was 3 feet, now it's 2 feet. But you really don't need any of that information. You're just focusing on these two values. All right. It decreased from 30 to 18. So the difference of 30 and 18 is 12. And now you just solve for x. Some people advocate cross products. I really don't like to use that. Just do the algebra. Get x by itself. Means you want to get rid of the 100. It's held by division. So you use multiplication. That's really 100 over 1. And then you do the same on the other side. I'm going to zoom in on this now. And we can clean this up some. On this side, obviously, those all 100 goes into 100 once. So you have x all by itself. Over here, excuse me, divide by 10 and divide by 10. That cleaned up pretty fast. This isn't showing up real well. This is 10. I still have 10 sitting here. Try zooming in again. There. And you can go a little further. 3 goes into 3 once. 3 goes into 12 4 times. So all you have to do is multiply 10 times 4. And you get 40. And don't forget, they want the percent decrease, and by putting this over 100, by putting x over 100, you've taken care of the position of the decimal. So now you have to remember to put in the percent sign. Okay? So this rectangle is 40% smaller than this rectangle. And again, it's a good idea to see if this makes sense. 40% is pretty close to 50%, and half of 30 would be 15, so that seems about right.